All right, imagine this. You've just moved into a brand new apartment. It is perfect. On moving day, the real estate agent hands you the keys and says something you really need to hear. And you're like, yeah, of course, got it. But then, life happens. You're drowning in boxes, you're trying to get the Wi-Fi working, you're figuring out where the good coffee shop is, and that little warning, it just completely slips your mind.
So, fast forward a week. You're out running errands. Someone walks right up to your brand new door. They don't have a key, they don't have a lockpick. All they have is a really common guess. And just like that, they're inside. No smashing windows, no sophisticated attack. They just use the password that came with the lock. All because of one simple, tiny step that was forgotten.
That story right there, that, in a nutshell, is security misconfiguration. According to the Open Web Application Security Project, or OWASP as we all know it, this is one of the most critical risks out there. In fact, it's ranked as the #2 most dangerous vulnerability affecting web applications. And you want to know why it's so dangerous? Precisely because it's so simple. So, let's dive in.
First, we'll break down what this actually is. Then we'll look at some truly catastrophic real-world examples. After that, I'll show you how to build a digital fortress to protect yourself. And we'll wrap up with a final checklist you'll definitely want to remember.
Okay, so let's get right to it. What are we really talking about when we say security misconfiguration?
So, this isn't about bugs in your code. This is all about flaws in the setup. It's when we forget to properly configure and harden our systems, essentially leaving the digital front door wide open from day one. And this can happen anywhere in your stack. We're talking the operating system, the web server, the cloud services, all the way up to your application framework.
Now check this out. Here is a statistic that should honestly be a little terrifying. According to OWASP's data, 100% of the applications they tested had at least one security misconfiguration. Not some of them, not most of them, every single one.
So, where do these flaws even come from? Well, it almost always boils down to these 4 things. First, and this is the big one, default credentials that never get changed. Admin/admin, root/password. It's literally the first thing an attacker is going to try. Second, unnecessary features that are still turned on. Think about a developer tool that's great for testing, but accidentally got pushed to production. An attacker finds it, and now they can see your entire codebase. Whoops. Third, error messages that are just way too helpful. Instead of a simple "something went wrong," your site spits out your database version and the exact line of code that broke. You might as well have just handed an attacker a blueprint to your system. And finally, missing security settings. All those little knobs and switches that are left in their default convenient mode, which is almost always deeply insecure.
All right, let's talk about what happens when these simple mistakes turn into absolute catastrophes in the real world. Because these aren't just theories. These things have taken down huge chunks of the internet.
You probably remember the Mirai botnet. Back in 2016, a piece of malware just scanned the internet for devices like home routers and security cameras that were still using their out-of-the-box passwords. It infected millions of them, turning them into a giant robot army. That army then attacked a major DNS provider and, boom, brought down Netflix, Twitter, and Reddit for pretty much the entire US East Coast. And the scariest part? A decade later, some studies show that up to 86% of routers might still have their factory default passwords. We're still making the same mistake.
Then you have NASA. They were using a project management tool called Jira, but because of a simple permission misconfiguration, access that should have been locked down to only NASA employees was accidentally set to, well, everyone on the internet. Thankfully, a security researcher found it first, but just imagine if an attacker had gotten there. They would have had a front-row seat to internal project plans, employee data, the whole shebang.
And of course, this happens in the cloud all the time. The U.S. Army Intelligence and Security Command was storing files in an Amazon S3 bucket. Some of these files were marked top secret, but someone misconfigured the permissions. Instead of being locked down for authorized personnel, it was open to literally anyone on the internet. The key takeaway from all of these stories: these weren't genius hackers pulling off sophisticated attacks. These were just incorrect settings.
Okay, so we've seen the problem, we've seen the absolute chaos it can cause. The good news is this is one of the most preventable vulnerabilities out there. So how do we build our fortress?
The fix isn't just one single thing. It's a disciplined process. We can really break it down into 3 core strategies. First, you need a secure blueprint to build from. Second, you have to be relentless about managing your keys and secrets. And third, you've got to actively turn on your defenses.
Step 1 is all about starting off on the right foot. This means you need a repeatable, automated hardening process. You start by establishing secure baselines using industry standards, so you have a rulebook for what secure actually looks like. Then, you automate your deployments with tools like Terraform or Ansible. Automation is your best friend here, because it eliminates human error. And finally, you have to be a minimalist. If you don't need a port, a service, or a sample app, get rid of it. The smaller your attack surface, the safer you are.
All right, step 2 is completely non-negotiable. Let me be crystal clear. Every single default credential must be changed before a system ever sees the light of day. This isn't a friendly suggestion, it is a hard and fast rule. You need a rock-solid process to replace every default password for your admin panels, your databases, your API keys, with a strong, unique, and properly managed secret. Never, ever, ever leave the factory settings enabled.
And finally, step 3 is about actively flipping on your defenses. This means configuring things the right way. Implement HTTP security headers to tell browsers how to interact securely with your site. Make sure your error messages are generic. They should never leak internal details about your stack. And when it comes to cloud storage, make the secure choice the default choice. Block all public access unless you have a very specific, intentional reason not to.
All right, let's bring it all home with the key takeaways. This is your final checklist to make sure you don't end up as the subject of the next disaster story.
First, this isn't some rare, exotic problem. It's universal. It's everywhere. Second, the attacks that exploit this are often shockingly simple. You don't need a hacking genius, just someone who knows the defaults. Third, prevention isn't about one magic fix. It's about having a disciplined, automated process for everything you build and deploy. And last, and if you remember nothing else, remember this. Defaults are built for convenience, never for security.
And that brings us right back to where we started. Every system, every application, every single cloud service has its own version of that 1234 password. So the real question you should be asking yourself is, what's yours and have you changed it yet?